In this video, we're going to look at solving problems with linear equations. An important skill in maths is the ability to translate written problems, I call them like English sentences, into algebraic equations or math sentences in order to solve problems. We'll do, again, by way of example. Let's look at worked example 8 from your textbook. Write the linear equation for each of the following statements. Let's use x to represent the unknown. And we're told we don't have to solve it, all we need to do is write the equation. So let's look at this first example here, 8a. When 6 is subtracted from a certain number, the result is 15. It tells us here to let x represent the unknown or the certain number. So there's our certain number in example A, x. When 6 is subtracted from a certain number, that's how we represent 6 being subtracted from this certain number. So when 6 is subtracted from the certain number, the result or the answer is 15. So we've just done there what the question asked. We've written this, I call English sentence, into a mathematics sentence. Okay, we've translated the written problem into an algebraic equation. Next example. 3 more than 7 times a certain number is 0. I always start, there's our certain number. So what do we have to do to that certain number? 3 more than 7 times the certain number. That's 7 times our certain number, x standing for our certain number. So 7 times our certain number, but we want 3 more than that. 3 more than 7 times the certain number gives us 0. I always write it and then reread the sentence that we started with to see if it makes sense. The next example. When 2 is divided by a certain number, the answer is 4 more than the number. So, when 2 is divided by a certain number, so we get 2, we divide that by the certain number. So that caters for the first bit. When 2 is divided by a certain number, the answer is 4 more than the number. So the answer is 4 more than the number. So remember the number or the certain number is x, and how do we represent 4 more than that? We write x plus 4. So let's check. When 2 is divided by a certain number, the answer is 4 more than that certain number. Yes, we've written that correctly. So in worked example A, we're not asked to solve them, we're just asked to write them. Let's look at worked example 9. In a basketball game, Hal scored 5 more points than Sev. If they scored a total of 27 points between them, how many points did each score? So read it a second time, just to help. In a basketball game, Hal scored 5 more points than Sev. If they scored a total of 27 points, how many points did each score? So what I'm going to do with worked example 9, I'm going to let x be Sev's score. So x is Sev's score. What about Hal's score? Hal scored 5 more points than Sev. So if x is Sev's score, Hal scored 5 more. So how do we represent that? X plus 5. So x is Sev's score and x plus 5 is Hal's score. In total, they scored 25 points. So if we add Sev's score plus Hal's score, so Sev plus Hal, the answer is 27. We have to solve this one. So let's look what we've got here. We can combine our like terms. So x plus x gives us 2x. So we've got 2x plus 5 on the left-hand side equals 27. Remembering undo according to SAMDIB, or the opposite of BIDMAS. So I'm going to take 5 from both sides. So 2x is equal to 22. Opposite of times is divide, so divide by 2, divide by 2. So x is 11. Now remember, what was x? X was Sev's score. So Sev scored 11 points. and How scored 11 plus 5 more. So How is 11 plus 5, so How scored 16 points. Now in examples like this started as a written question or a sentence. So we need to finish it as a sentence and write something like Sev scored 11 points and How scored 16 points. We must write that as our concluding statement. Hey, let's just double check. In total they scored 27 points. Yep, 11 and 16 does give us 27. Let's look at worked example 10. A taxi charges $3.60. So that's $3.60 as soon as you call it. It could be sitting there stationary, you still pay $3.60. And then you pay $1.38 per kilometre. Her taxi fare was $38.10. How far did she travel? So I have to scroll down here. Hang on, I'll see if we can get that question down. Okay, so I've just put the question down so we can see it where we work it. So let's say, let x be the distance in kilometres. Right, so how do we represent this? It costs $3.60 as soon as we call the taxi. And it costs $1.38 per kilometre. So for every if we call x the distance in kilometres, if we've got to times that by $1.38, and that will tell us, for example, if we travel 10 kilometres, then we put a 10 here. If we travel 5 kilometres, we put a 5 there. Anyway, $3.60 to get in the cab, plus $1.38 times that by how many kilometres, and Eleanor has spent $38.10. So what we're trying to work out in this is we're trying to solve x. We're trying to work out how many kilometres did she travel. So I'll just write it again a little bit neater. $3.60 flag call plus $1.38 per kilometre, and she spent $38.10. I'm going to take $3.60 from both sides to cancel that out. So I'm going to take $3.60 from this side. So then I've got 1.38x is equal to $34.50. Divide by 1.38, cancel, cancel, divide by 1.38. That gives us x is 25. So our sentence, because it started as a sentence, Eleanor must have travelled 25 kilometres. Okay, in these, my biggest tip, I guess, is once you've written out the algebraic equation, read the problem again, the written problem, and just see if what you've written does actually make sense. So some questions will ask you just to write the algebraic equation, like in worked example 8. Others will ask you actually to solve them.